Good evening, and welcome to another of our 2023 General Mathematics webinars. I'm Daisy Patsias, and I will be your host for this evening. Tonight is all about Leslie matrices, and you're in great hands, everyone, because presenting is Peter Fox. Peter doesn't need much of an introduction. I'm sure most of you all know him and know how brilliant he is. So we're in for a real treat, as I've had a sneak peek and can tell you that Peter has really planned an exciting session. Welcome, Peter.
Thank you, Daisy. I assume everyone can hear me?
Well, I can. That's all that matters, right?
Hopefully some of our participants can hear and we'll be able to have a chat along the way. We do have a fairly full session, but we usually have time for a few questions along the journey. So if people want to enter some questions in the chat, either myself or Daisy may be able to answer those questions for you. But other than that, we're going to get straight into it. We're going to look at Leslie matrices, for example, why we use them, how they work, and then finally how you can build an interactive document such as the one you'll see in tonight's session, because it will increase student engagement and understanding. So right at the start, why do we use them? Well, they're a type of transition matrix. So if you've never heard or seen of these objects before, you may have heard of them as transition matrices or may have heard of transition matrices. They're typically designed to model the change in age distribution over a time for an animal population. That doesn't mean you couldn't use them for the human population, but there's a lot more variables, I guess, that are in that, but they were designed for animal populations. So what animal population are we going to use? Well, I do have a vague sense of humour, so we're going to use the dung beetle as our population that we're going to model. The typical lifespan of the dung beetle is 3 years, so it works quite nicely with our matrix. We're going to categorise each age group. For those of you that don't know what a dung beetle is, these little environmental wonders live on the feces of other animals. And yes, you heard that correctly, feces, not faces. Ironically, these poor little critters have a strong sense of smell, and that's used to help them locate a big pile of dung. They select a piece of poop, roll it up into a ball, and then the female clings to it while the male pushes it along back to the nest, where the female will lay her eggs, put them in the dung ball, and then the eggs hatch and the babies eat their way out. Pretty grotesque, isn't it all? But it's now time to get on to the mathematics of the whole thing. So obviously we can learn about Leslie matrices. So our first little dung ball rolls along here, and I've said, just to put some figures on this, we'll say that juveniles, that's our little baby dung beetles, have a 40% survival rate. So this is the sort of information you're given and then required to set up a Leslie matrix. And our second age category we're calling adults, and they have a reproduction factor of 2. That's not to say the males can do it, it just means a reproductive pair would produce 4. It's just going to make the maths a bit easier. And a 35% survival rate. I guess that tells you don't eat too much crap. All right, and then finally we have our senior dung beetles who have a 0% survival rate, but are still able to reproduce up until the time that they are deceased. So that's our information. So one of the formats that you might receive this information in, other than text, is in like a network sort of a map. So here it is in a different view. So we can see that the juveniles on the far left of screen, they progress to become adults, excuse me, of which about 40% survive. And then the adults go on to become seniors, and there's only 35% of those surviving. And we see that the adults reproduce by a factor of 2 and the seniors reproduce factor of 1.5. But of course, they're reproducing junior burgers. So in year 0, so we need some sort of initial starting population to explore what happens to the number of dung beetles overall. So I've got J0 for our juniors, initial adults A0 and S0 for initial seniors. So in year one, what would that look like? And this is the sort of thing I think is useful to students before you just throw them into a matrix, is to get them to work it out piece by piece and say, so let's have a look at juniors and ask ourselves, how do we work out how many juniors are going to be present next year? Well, it doesn't matter how many juniors we have at the start, they're not going to contribute to next year's juniors because they all progress to adults. But we would need to look to the adult population, and for every adult, we'd get 2 new juniors. And for every senior, we get 1.5 new juniors. So that's how we'd work out J1, in other words, the number of juniors in year one. Then if we wanted to look at how many adults we'll have in year one, we know that we get 40% of the current juniors. Current adults don't produce new adults, and current seniors don't produce adults. So the only thing contributing to next year's adult population is the survival of the juniors. So you can see there's a lot of zeros in here, and that'll come out in the matrix shortly. And of course, our seniors, we get nothing from our juniors in the previous year. We get 35% of the adults from the previous year. And of course, no seniors remain to stay on as seniors the following year. So there's lots of zeros in the matrix. So year one, that's it. And we update our little subscripts there. Year two, same sort of thing as we saw before, except obviously we're referring to the number of juniors in year one, the number of adults in year one, and the number of seniors in year one. And so we see the same sort of thing for adults. We're referring back to, so it's recursive, what we're saying in a nutshell. And when it's recursive like this and set out like this, we can see that it lends itself to a matrix. So let's have a look what that matrix would look like. Our first row, we would see 0 times, so we're going to create a 3 by 3 matrix, and we're going to multiply it by this population matrix, often referred to as a population vector. And we get 0 times the current or the initial juniors, and then of course 2 times the adults from our first year, or our 0th year, our initial population, and then 1.5 seniors from our initial population. So we can see that's just basic matrix multiplication that's going on here. Now this first row is often referred to as the fecundity row, because it's the reproduction rates and they appear across the top of the matrix. So we can see where those figures have come from. And let's have a look at the second row. I think you've probably figured out what's going to happen there. So our second row is about the adults. So we know that 40% of juniors will then progress to become an adult. 0 adults will become adults in the next generation, and of course the seniors don't contribute either. And as I said, you can see the zeros starting to populate in our Leslie matrix. And our last row in the matrix is our adults, and we should now be expecting a 0 in the first column there, because that's the transition from juniors into seniors, which we don't have. And it's the adults that reproduce to become, or don't reproduce, but progress to become seniors. And of course, no seniors survive. And that's our matrix operation. So we can multiply our initial population vector by our Leslie matrix to get the population in year one. So it follows that if you then moved our year one population in there, we'll get the population for year two. And then of course, year three, and year 4, and ultimately we'd want to just put an n in there to work out the population after n years. So there's a lot of calculations that we'll be zooming through there once we start to put an n in there. But of course we're also interested in the total population. We're interested in how each population changes with time. So there's a lot going on other than just setting up the matrix from the data, but that's certainly a part of what students would be required to do. So With all that information, I think it's probably time to have a look at the calculator activity itself. So this one you can download from the website, so don't be scared if you can't create this. But what I will do in the second half of this webinar is show you how you can create this sort of stuff. So we'll swap over to our calculator. That's what the calculator file looks like. So you'll recognize it from our little dung beetle characters. They look a lot nicer than the real beetles. And here's our Leslie matrix. And we have some initial populations from the question sheet that's available. But before I jump into this one, let's see how you might just do it without this particular document. In other words, if you're just setting it up so that you can, do it yourselves, or students might do it. There's some calculations I was doing before, so let's just create a new document. I'll put a calculator application in, because there's a few nice little tips here I want to give you on creating matrices as well. So we know we can create a matrix through the maths template. We know that we can create them through the menu, create matrix, and we get this option to create the number of rows and columns. We can also just create one, and if you're using your computer, then you can actually do it with square brackets as well. So the first row had something like that in it. And notice I've just separated each element in the first row with commas. Well, if I use a semicolon, then that produces the next row. So that was 0.4, 0, 0, and the next row was 0, 0.35, 0. And then when I press enter, you'll notice it automatically jumps into our Leslie matrix. So there's all sorts of ways that you can create the matrices. Obviously in here, not that one, but that one. And that gives you the same as what the menus did, where you can just automatically create it with the number of rows and columns. Now, the first thing we had to do is multiply it by some sort of initial population. Well, in the activity, the one that's on the website for this particular task talks about a farmer who purchases 100 junior dung beetles and then throws them in the paddock or in his barn and lets them start reproducing, and what happens to the population. So he only gets 100 junior beetles. So we need to get that, our Leslie matrix, and multiply it by our population matrix or vector. Now you notice I just put in a 2-row 1 column, but let's see what happens. We said 150, 0. Now here's another little tip. You've created a matrix, it's the wrong dimension. We know it's going to give a dimension error, but there's some shortcuts. Control, Shift, and carriage return will drop another row in. So if you're ever building a matrix, if you just press Shift and carriage return, that'll drop another column in. So you can just keep on adding more and more columns if you wanted to. I don't want to, so I'll undo that. And obviously you can use the arrow keys or the tab keys to navigate. So that is our population at year 1. You may be asking what happened to all of our junior burgers. Well, they all progress, or 40% of them rather, progress to become adults. We don't have any seniors yet, because the only way to become a senior dung beetle is you've got to pass through this stage. So that's year 1. If we want to know what's happening in year 2, then we go back and we get our initial matrix and we can multiply it. And I'm just copying and pasting here. That is just arrowing up and pressing enter. Press enter again. And now we have 120 juniors. And you think, well, why did we suddenly jump to 120? Well, remember that for every adult, and we had 60 adults, they produce 2 juniors in the following year, which is why we're now up to 120 juniors, from 0 up to 120. And the survival rate of the adults as they progress to seniors is 35%, so 35% of 60 is 21. And because we had no juniors last year, we don't have any adults this year. So you can see what's going to happen now is because we've got such a small senior population and no adult population, the following year we're going to get very, very few junior beetles. So we can go back up here and multiply by our previous year and just press enter again. So you can see our population jumped from 141 and it's down to what, almost 80. So the population is declining, and we would be nice to sum all of those things up, and that's what that activity does for us. The other thing you might want to do here is I'm going to store L assigned equals to is a nice one, which is the control and mass template on the keyboard. And I'm going to go up and get our initial Leslie matrix. And I'll go and get the initial population vector, the one that we started with. Whereabouts have he gone? There he is. And I'm just going to put that there. So now I can do L times answer. So that was our population after year 1. Now, don't be confused, because I used answer. Watch what happens if I press enter again. Notice it's pulled the previous answer down and dropped it in for us. So that was after 2 years. Press enter, that's 3 years, 4 years, 5 years, 6, 7, 8, 9, 10 years of growth for the juniors, adults, and seniors. I think when you look at this, you can start to see that it seems to be about 60 or 70 juniors and about 20 to 30 adults, and not too many senior beetles hanging around. I'll press enter a couple more times. And now we're starting to see that it's sort of stabilizing. It jumped around a lot at the start, but now it's stabilizing. And that's one of the things that students will be asked, I believe, when they're working with Leslie matrices is, what is the stable state? What are we heading towards? Well, that's great that we can do it that way, but let's see how that looks on here. So this is a document that you get with the activity, and you can see there's our Leslie matrix for the conditions that we had before, and we can start with, let's say, 150 juniors, no adults, no seniors, and it says, well, go on to the next page, so we can do that. And on here, it's kind of cool. It says you've got 150 juveniles at year 0, and it's graphing it for us. So we can see the junior population takes a massive dive after 1 year. Adult surges up because there weren't any, and the seniors are still not around. And now we can see the seniors are starting to join in. We have the blue one, we have quite a few juveniles, and the black line is our total population, so we can watch what's going on. It's very noisy at the start, jumping around all over the place. But after 10 years, we can actually see it's starting to stabilize. That black one, remember, is just the total population. So our total population seems to be sitting or stabilizing around about 120-ish. Just a bit shy of 120. We started with 150. It's tapered off a little bit. But we can certainly see that the seniors, adults, and juniors are all approaching some sort of a regulatory value. We're also interested in the ratio between these, which we'll have a look at shortly. Now, in the activity, the question is also posed, what if you, as a farmer, bought a different proportion? So how is all this working, by the way? If you haven't recognized already, this is a notes application. That's allowing me to make these edits. So I'll go in here and I'll put in 50. So the farmer in the problem, the activity, says, well, rather than buying 150 juniors, what if I bought 100 juniors and 50 adults? Would that make any difference? I've still got exactly the same total population, and none of this has changed. Let's try. 1 year, 2 years, 3 years, 4 years, 5 years. We don't have the noisy values at the start. The only one that's really jumped around now is this senior population, because we didn't start with any seniors. The other thing you might notice now is in fact, that the total population hasn't dropped below the 150. In fact, it's continued to increase. Well, it turns out the other population was increasing as well. It just wasn't as obvious. It was still in this sort of noisy bit at the start. We didn't see the increase. And as it turns out, there's some cool stuff you can do with Leslie matrices and something called eigenvectors and eigenvalues. Now, as a heads up, eigenvectors and eigenvalues are not included in the General Maths VCE course. I know they are in some other states, so if you're watching tonight from, say, Queensland, I know that they do refer to them up here, or up in Queensland rather. I wish I was in Queensland. But let me show you how easy it is to get these values, these eigenvectors and eigenvalues. In fact, in this document, I dropped them in down below. Now, these numbers might look particularly ugly right now, but what this 1.004 is telling us here is that our population is generally increasing ever so slightly. And these values actually give us the proportions. And you'll see that when I do a calculation here. So these ones, I think we can see, tends to be sort of stabilizing. So what about the ratios between juveniles, adults, and seniors? So let's do it for, say, 20 years, and we'll use these figures. So let me just write them down. I'll grab a pen. You can write them down yourselves if you like. We want to work out what is the fraction of juniors out of the total population. So 112 plus 44.5 plus 15.5. So let me just go back to the previous page. I'll put in a maths box. Control M is the shortcut, or you can get it through the menus if you want, through here, maths box. Menu, insert, maths box. And I want to do a calculation, and we want to see what proportion of our population is represented by the juniors. So 112 plus 44.5. Interesting that we can have half a beetle, but anyway. And we get this. 65% of our population is comprising of junior beetles. Well, now let's have a look at these figures down here. This column, which is directly below this one. So this is our eigenvalues. This is our eigenvector. So I'm going to put in this fraction, 0.9214 over 0.9214 plus 0.3669 plus 0.1278, and lo and behold, it's pretty close. And of course, the further I progress, the closer and closer this will get. This is actually telling us the ratio that we're heading towards. So ultimately, juniors, with our current setup, will represent approximately 65% of the total beetle population. It's also how, of course, scientists can figure out, well, based on our figures, what should our juniors be? And if it's something completely different, then we know that they might be in some sort of different state. That's all the biology behind it. Now, another thing in this particular one, so what we're doing is getting students to explore it. So one of the other questions, and let me just go back to our original values of 150 and 0. So I'll go back to what the farmer originally purchased. And it says that the farmer has found some sort of a spray that wards off the animals, if you like, or the other bugs that tend to eat the larvae or these junior burgers, the poor little baby ones, baby dung beetles, and we get a slightly higher survival rate. So we're talking about an increase there, 5%, up from 40% up to 45%, so not massive. Should it make a difference? Well, we kind of expect a few more beetles to hang around, and look at that. Let me just go back to the start. We still see the same noise at the start, but we can see that the population is increasing quite rapidly. So let's go back again and say, well, the farmer also looked at what if we had 100 there, 50 there, and no seniors. We haven't got any senior beetles here. And watch what happens. We're like right off the charts here. The population is exploding. Before we couldn't even make 150. Now we're out to almost 300 of these little critters. By such a small change, one tiny little change. So a couple of things are happening here. The first thing we want students to realize is, why is this performing so much better than exactly the same at the start that we had before? Well, that's because when I order the beetles in quantities that closely reflect the long-term population, we don't get the noise at the start. If I just back that one off just a little bit, and we'll go that down to about 95, just rough numbers, and that means we can have 10 seniors. Now you'll see that as we progress, the noise at the start is almost gone because we're almost at those long-term proportions, and you can see now with the retention of, or the survival rate rather, of the juveniles being much higher, the population skyrockets. In fact, it's almost a nice curve there, isn't it? Let's go back in here. I'm going back and make these values back to where we were before. And would the same happen if we change the survival rate of seniors, or sorry, adults? Now, the other thing that I'm doing here is I'm going in and editing the matrix each time. So it's not that students have to create 1,000 of these things, or you need to come up with 200 different scenarios to get the students to practice it. By the time the students have gone in here and edited each of these terms within the context of the problem that we're looking at, they know exactly what these refer to. They then know this is the survival rate of juniors as they become adults. This is the survival rate of adults as they become seniors. And up here is the reproduction rates, which we'll have a look at in a moment. And then we can just scoot along here and see that we do get the population increase, but not quite as much. Now, the other thing that's kind of cool is we can see, remember the original one was like 1.004? So if I went back to our original conditions, where that was 0.35, we can see down here 1.004. That's a measure of the growth rate of our population. So increasing the survival rate, let's say bumping that up a bit, we can see that the population is growing more rapidly. That's what these eigenvalues and eigenvectors help tell us. The rate at which the population is increasing and the proportions under which they are doing that. So I think even though they're not in the course, it's worthwhile including it, because you can see all I've typed in here is eigenvalue, and I've put in my Leslie matrix. I don't have to do 200, 300 simulations to get there. Eigenvector of my Leslie matrix, and it returns this. You don't need to tell the students how to do those calculations, just they exist, and that's what that will give you. So I think that's worthy, particularly since the students are not having to do any extra calculations. If you're wanting to know where that information is stored, let me just put in a calculator application menu, because that's all related to vectors. I think it'd be fair to assume I'll find it in the matrix and vector menu. Went a bit far. And it's like, well, where could we find this sort of information? So I'll just scoot on down. Maybe it's under advanced. And there they are, eigenvalues and eigenvectors. And that's all I did with my Leslie matrix, and there it is there. Pretty simple. So how did I create this document? So I said before at the start of this session that I would spend some time showing you how to build this particular document. How is it that I'm able to just arrow through on this slider and track the population, which I think is a very important thing in this, to show the students why we're using Leslie matrices and what information we can extract from them. Most of the grunt work happens between the notes application and this spreadsheet. So the spreadsheet, well, this obviously is just generating years, and I'll show you how to generate years. So I'll open up a new document. Let's get rid of that one. And we'll create a new document. And I have a graphs application. And all I did was put a slider in it. So actions, insert slider. I called my slider N. We'll start with 1. We'll go 1 to, let's say, 10. And steps of 1. And there's my slider. I think everybody's probably produced sliders before. So I can just click on it. So then, if I put in a spreadsheet, and I can call this years, I think I did on mine. And in here, what I want to do is generate a sequence. So if I put in equals sequence, because anytime you're going to put a formula, you're going to start with an equals. And the formula is actually really simple. If I go x comma x, and we'll start at 0 all the way through to n. So x is my variable and x is the formula. That'll make sense in just a moment. It wants to know this n to which you're referring to, is that a column? Nope, it's a variable. And you can see that it's gone 0, 1. So if I click on here and go to 2, it's now gone 0, 1, 2. Click on here, it's now 0, 1, 2, 3. So that's how I'm getting the data to just continue to populate. And the good thing is, if I wind it back, it just goes from 0 to 1. So it's just producing a sequence from 0 up to n. The other one I had was juniors. So how did the juniors come about? Well, that's where you need to know a couple of little tricks. So let's put our calculator application in. Well, actually, I'll put a notes application in, mainly because it allows me to do calculation after calculation, recalculation. So you'll see how that works. Our Leslie matrix, what I should do is just go across to here. This is something you can do on the software, of course, that you can't do on the handheld. I'm just going to cheat, Control C, and let's see if that works. Control V, look at that, that's nice, I love that. And I'll call this, just to be different, I'm going to call it M for matrix. Now, the command that most people probably are not aware of, if I wanted to say extract a specific value out of that matrix, I'm going to put a 2, 1 and see if we can figure out what it's doing. Let's try 2, 3, 3, 1 rather. Let's try and see if we can extract this value. So third row, second column, and there's our value of 0.45. So at any time, I can extract information from here. All right, let's get rid of that. So we had our population vector, which I'm going to call P this time. And we said that that was equal to, what was it, 150, 0, oops, I need to use semicolons. So here's where you have to be careful. This is probably the only sneaky bit, is if I do M times P here, I've got my population after 1 year. If I did something like this to the power of n, which is my slider value, you can see what's going on here. And then when I jump over here and make that 2, it's now jumped into my second year. That's kind of cool. If I change it to 3, I've got that. So how do I get the 40.5 off to figure out what the population of juniors in my total, or number of juniors in the total? Well, I'll put that in some brackets to force that calculation out. So now that calculation is still a matrix. You notice it's dropped the brackets off. It says you don't need them, but I need it to do the calculation first, And then if I'm after the junior population, I want the first row, first column, and there it is, 40.5. Let's go back to here. So if I spin that back to 1 year, we shouldn't have any juniors around. We haven't. So that's how the whole thing is working in here. Now that N, let's go back in here. I could just use these values here, but I chose to generate a sequence. So I said, let's do a sequence. And I wanted exactly what I had on the previous page, m to the power of n, times p. And then for juniors, I want row 1, column 1. And that's my formula this time. And I think from memory I should probably use an X here. And I want it to go from 0 to n. And again, it's saying, oh, you've got an m in your formula. Is that the column m, or is it the variable n that you defined? It's a variable. And it says, oh, what about this p? That could also be a column. And by the way, if you want to avoid doing this, you'll notice, and I'll show you the formula at the end of it. Oops, it's missing something. What's it missing from there? Oh, we're missing a variable x. Oh, now it's going to go through again. Okay, I'm going to cancel that because we can actually avoid doing those things by just adding that. When I missed the n. Oh, I missed the n down here. Variable. And there it is there. So now, as I run this slider through, you can see it's starting to populate. And then all I did on the graph was did a scatter plot. So I said, let's do a scatter plot. And I want years on the x-axis, and I want juniors on the y-axis. Probably worthwhile doing a zoom data. And then we have to think about how many might be present. So you can see it's jumped down. And we go, well, let's jump that up to, say, 200. And we'll do that in jumps of 1 year at a time. And probably needed to fix up the y-axis scale. Let me just change that. Window zoom, say in -1. I'm going to go for 10 years, scale of 1 year, -10, 200, and let's say 25 seems like a reasonable scale, and that looks a bit better. And then I just hid that label there, like that. And I did it as a connected scatter plot. Change your attributes, connected scatter plot. And now we can track junior population. So I think you can see that if I wanted the adults, it's pretty much the same formula as what I did in here. So I'm going to cheat. I'll just copy it. And I'll go into here and I'll paste it. And we actually want the second row. And there's our adults. Go in here and paste it. And we want the third row. And that was our seniors. And of course, the total, you could add those things up individually, but that would just be messy. So totals, all we need to do is say that equals juniors plus adults plus seniors. Oops, it'd be good if I could spell senior. There we go. And then we're ready to go with all of our graphs. We just literally add those extra scatter plots on. So we want years on the x-axis and we want adults. Now, this is not something you'd be getting students to do. This is something you set up as your activity if you want to mimic something like the one that you saw on the website. And of course, if you want to change the matrices, you can just come in here and set them up to whatever parameters you want. So changing that on here is now going to update everything that's happening in here. And it's going to, well, it's already updated. You can see it's already changed. I need to hide that label. and do these as a connected scatter plot. It just makes it a little bit easier rather than having all the dots all over the screen. So hopefully that gives you some idea on how to set these things up and what sort of tools are available to you. Now I'm just checking the chat. Daisy, has anyone got any questions? I've got a couple more minutes. I've got another 5 minutes we can run through if anyone has any particular questions. Otherwise, I can show you a few more things.
Nothing's come through yet, Peter, but we do welcome you all to ask questions, I should say.
All right, so what I'm doing, just in case people haven't got any questions, we've still got a few more things to go through. So you saw to create a matrix, you can do that through the math templates. You can do it through the menus, matrix, vector, create matrix, all of those work. But also if you're doing it on your computer, using the square brackets, comma, separates the elements, and semicolon will separate the rows or create a new row. You saw before that shift and the carriage return, no, not enter, but the carriage return, the one that looks like a little back to front arrow. It's like what it looks like on your computer keyboard where it has that little funny arrow thing on it. That creates a new column, and Control Shift will create a new row. The other thing is storing the matrix as a variable. So rather than having to go back and copy and paste it all. Now, the other thing which punters might not know about is if I press the variable key, you'll notice in here, it says adults, juniors, and seniors. This little icon here tells me that that's a list. This little icon here tells me it's a numerical value. If I go back to here in our Leslie matrices, if I look under here, you can tell L is assigned to a matrix. Have a look at the little icon. So you can tell what everything is in here. R is a number, SE. I've used some abbreviations in here previously to do some data capturing to see which way was the best way to do it. So just be wary that you can store it as a variable and you know which ones are variables as matrices because of the little icon. A few other things about Leslie matrices. Don't forget you can download the activity from the TI website. Let me jump across to you and show you where that is. So if you land on the Texas Instruments website and you're trying to find these things, you go across to Teachers, click on Senior Curriculum Inspirations. And if you're in Victoria and you're doing this for the Victorian series, it's currently called Further Maths because we didn't want to confuse people by just putting General Maths Year 12. So you'll find them under the Further Maths course at the moment, Matrices, Leslie Matrices, and the all files is that one. Let's just have a quick look at the student file so you know what to expect there. Where are we? Student activity. There it is. Just take a moment to load. That's what the activity looks like. It's pretty cool, isn't it? There it is. So all the introductions, dung beetle warm-up, the questions as you saw before, and telling students to go through, have a look at the matrix, then screenshots to show what to expect, and an extension activity. The biological balance can be quite delicate, relatively small change in the ecosystem, and then ask them to go through, and it mentions the eigenvalues. So if you don't want students to go into that, just tell them not to do the extension. And of course, all the answers are on the teacher sheet. So don't show students where this is because then they'll be able to download the answers. And the TI-Nspire file that I've been using today or in this session is located right there. There are other activities introducing matrices, but that's the one on Leslie matrices. If you're looking for other resources on Leslie matrices and you're from Victoria, just as a heads up, Queensland has been doing it for quite some time. So you'll find that Leslie matrices, if you're looking up the Queensland curriculum, you'll find other examples there. Always good to know. And really cool, you'll also find if you download past exams. Now, Queensland's only been doing exams for, I think, this is their 3rd year. So you'll be able to find sample exam questions on Leslie matrices in past Queensland examinations. So I think we're just about at a wrap now. Daisy, we said 45 minutes, and that's just about me. Sorry, one other thing I will mention. Dung Beetle walks into a bar and asks, "Is this stool taken?" Sorry, couldn't resist that Dung Beetle joke. I was showing Daisy earlier on. There's a really hilarious video by a guy by the name, he calls himself Z.E. Frank, on dung beetles. I found that one on YouTube. Could be a good introduction for the students. Nothing to do with Leslie matrices, just the dung beetle. If you're after stuff on Leslie matrices, another video, I found this one by the amazing Peter Jones. That is also up on YouTube. It was something from Cambridge Press. And I guess the last thing is to say thank you for joining us.
Thanks, Peter. Actually, a couple of chat questions did come through, and they were asking about getting access to your files. So just like I said in the chat, in the next couple of days, you'll receive an email that will have a link to the recording so you can watch it again. And in addition to that, to Peter's files, a link to the worksheets that Peter mentioned on our website. In addition to that, you'll also get a link to your PD certificate. So we thank you very much, Peter, for your presentation, and we thank the audience for watching today. And hopefully we'll see you next time.
Thank you.